With the coming into view of a quantum mechanical picture of matter and of all that exists, many of the ways in which physicists had to were thinking nature had to change. Pre-quantum world, Newton thought of objects as being made of, and the particles had mass, they had size, motion, other attributes that later were added on, like electric charge. So object so that in a Newtonian picture of physics, everything was made out of particles, and the particles could be measured. Every aspect of them could be measured, so that particle object or the matter was identical to observables. Everything you could think about, you could measure. Quantum mechanics changed that in a profound way. Quantum mechanics began to show us that whereas matter obviously exists, the thing that about it, the position and velocity of an object are simultaneously knowable with arbitrary in the same. So in these ways, it gives us a sense of humility about our level of knowledge. Matter is there is about it, but there is a very long and in fact going question in the field of quantum foundations. What is actually going on, really happening to matter, so that it behaves the ways we see. A simple experiment that often used in mechanics, they talk about a double-slit experiment. So in a double-slit experiment, you can see a situation where you have particles, you have a wall, and the wall are, let's say, two holes. There's one hole in the wall, and you have a detector. And let's say bullets. Eventually, this back surface, you see a pileup of incidents, of hits, of events. When you look at the distribution, you see now you do the experiment. You open this hole, you the other. Now from this one, you do the same thing. See this? It's just another distribution. Now the strange thing is that when you open to see just the, in other words, they would add together. In fact, you see a pattern that looks like an looks went through, and in some places C is less with both holes. With that, I opened the second hole and here, and this first hand something very serious or something very strange is happening as involved as well. Now the question is, why do we then have a coherent, consistent ontology, which means a description of existence that is consistent with the nature and the wave nature? And that's been a subject of great mechanics. And at this point, there is not a definite answer. And this is an area which is still needing a lot of work. Whereas can quantum world to predict the results of experiments extremely well, we don't have a clear understanding. Mathematician is proposing these days quantum mechanics, in which he's invoking essentially a classic picture. It kind of goes, for example, what the Greeks would have called the perfect conceptual picture, whereas the highest, which is the substrate of matter, and the which is the shape of the matter. If you think of a marble, the marble, a big marble, there is a statue is in there, but until the sculptor actually put shape in, carves that shape out of the marble, there is none of the statue in it. It's the statue, but it's not really in there. It's really that the statue is. The marble is also not a statue. Together. So Wolfgang kind of uses to say in reality there seems to be at one level corporeal world of objects we see, but then in another world of the physicist, which is something in between sort of this corporeal world and sort of the high kind of space, the Greek hyle concept, and that there is the potentiality talks about is really in this in-between state, which Schmidt the physical world makes for a called ontology. It's like I fully grasp. Tell you, which tells us there is still exciting work ahead. That even understanding the very basic nature of matter is fully grasped. It's a humbling thing that God created in with more depth and detail. Our simple can just dispatch look like, oh yeah, everything. No, there is a